our last lecture today is intelligent security for IoT. Okay. So, intelligent means we have been using this machine learning, deep learning. Okay. Then we are also looking for reasoning. Okay. Now, some are computation, but making decision making process. So, we have been covering all those things. Initial title I gave for this lecture was machine learning and deep learning for IoT. It still stands, but I make it short. Machine learning slash deep learning, nothing but intelligent. Okay. So, the idea is IoT needs security, and no dispute on that. Then security is in fact is one of the biggest weakness for IoT survival and functional performance. And when you say intelligent security, it means we are trying to see all that technology algorithms that use machine learning, deep learning, how they can be applied to help IoT and keep it more secure. Okay? So, we would like to keep the IoT secure using our machine learning or data analytics, you can say. So, data analytics for a secure data analytics for IoT, you can say. You can put many names, but the purpose is same. You want to see IoT secure, you want to use the technology, data analytics technology to do that for us. Yeah, this paper, there is reference paper there in that first page, so that you can go back and check it. Okay. Now, the scope is introduction and motivation. I told you a bit of that. Then potential attack surfaces, IoT systems. Okay. I am sure if you have taken this wireless sensor network and various attacks, intrusion, okay, you know all these things. Okay. So, we will be using those things, but will not explain something inside. Okay. Then we will talk about machine learning and deep learning methods for IoT security, that is the core of the lecture. Then some applications, you can go through each IoT layer. We will do it briefly, so that you can say okay, which layer of IoT, what kind of which machine learning data deep learning can be applied to. Then we have some challenges and future directions, and that will be hopefully in 1 hour. Okay. We know that the serious large scale IoTs, they typically work in the field and mostly unattended. It could be the forest, it could be weather monitoring. Most of the time they are not attended. Okay. Now, anybody can just steal it away, including animals. Okay. Or perpetual guy who want to do that nuisance. Now, IoT devices mostly connected over wireless network. Okay. So, somebody can always go and access the private information using eavesdropping. So, eavesdropping is, you know, eavesdropping everybody, right? Go to the next channel and try to listen what is going on, and grab that and follow the sensor and the sensor holder. Okay. Now, IoT systems are complex, very large scale. They are typically, you have seen, because of the layer arrangement and connected with the sensors and actuators, is an integration arrangement or an integrative arrangement, which means there are many objects are there and large numbers, and somehow they been together through integration. So, what it says that if this is a scenario, if there is an attack at one part of the system, then entire system can be challenged and could be compromised. Okay. So, we have to have higher security arrangement for IoT systems, and knowing that that also needs some computation. So, basically what it is saying, security is at a higher risk in IoT compared to simple computing systems. Okay. So, that also tells us any technique we have used to keep the computing system secure using those antivirus stuff, okay, that is not going to be applied here. Okay. Now, if you want to see the big picture, that what this lecture is about, what you see here, this is your IoT systems. So, because the IoT system and there are also risks, so there are threats coming from various sources. Our goal is to ensure that they are secure. How will do that? By monitoring it. So, your monitoring system supposed to check the monitoring and say the system is normal, safe, nothing has gone wrong there. Or the monitoring system can tell, based on the data I am analyzing, I could see that there is possible an attack soon. That is called attack prediction. That is an early warning signal. Or your monitoring system can say attack is already there. Okay. The three scenarios your monitoring system can do. Now, how will do that? You need prediction, you have to ensure that everything going well or attack has been there. So, you need some kind of a gadget here which has machine learning, data learning techniques built into it that can make some decisions, that can give an alert one of this. And to do that, it has to go and monitor all these systems in place. So, if everything works nicely, that is called normal mode, then it is good. Or if somebody is already there hiding and attacking infrastructure, objects, applications, then your IoT system is already under attack. So, you get signal here, get signal there and decides and choose. So, we will be focusing in this area. This is called taxonomy of machine learning, data learning for IoT security. Okay. Now, we have that 4 different areas to look into. One is threats, security threats, then learning method for IoT security, that means you are watching and seeing what is going on, so that new attacks could be observed, could be detected. Then machine learning for different layer of security, because your IoT has several layers and each layer has a different scope of being attacked. Then other dimensions. So, the taxonomy description is given here, all possible discussions given here, okay, under these 4 categories: security threats, learning methods. Now, let us take any one, let us go from here left to right quick. Okay. IoT security threats, that is IoT security threats types, that is cyber threats, physical threats. Physical cyber, physical means somebody take it away physically, or attacks using various internet means. Okay. Then IoT security threats surface, surface means where the potential places attack will be there. Okay. Again physical surface, network surface, then all the layers basically surfaces. Then learning method for IoT security is using machine learning or deep learning. Under machine learning, we have got some supervised and unsupervised, those traditional things including reinforcement. And deep learning, we have similar things, but we have got deep reinforcement methods. Then under supervised, we have got all those SBM, MB or classical ML techniques, numerical methods. Unsupervised K-means, and these are something we have, you might have come across. They are traditional machine learning techniques. Okay. And CNN, RNN, autoencoder, all those things are listed here, because taxonomy, you have to see what is being used where. Then machine learning for layers, various layers, you have to see perception layer, network layer, application layer and so on. Okay. And the other dimension is, there is besides the standard things that we know so far, there are new things coming up. Attacks on data, attacks on learning strategies, attacks on the weakness of machine learning and deep learning, and attacks on place where they are integrated and system as a whole. And each one essentially further dissected, okay, saying okay, if it is machine learning, data learning challenges or weakness, then what are they? What is misuse of machine learning by hackers, or trying to compromise privacy or security of machine learning, data learning. So, all those things are part of those details. So, this slide essentially gives a broad scope, but all the names, titles, the relationship between them, they have been put together. Okay. That is one, they call it, what they call it? One place to get everything. Okay. So that is the one place you can see the entities and relationship. Okay, this is just to, I am not going to talk about it because we already talked so many times these things. They are 3 layer, major layer, but further details. Okay. Why machine learning, deep learning for IoT security? Why not something else? Because machine learning and data learning can analyze the environment, then they can detect whether something has happened in terms of security. Okay. So, there are many methods, okay. They have been already existing, and all we are trying to do is trying to use them, get them and use them and for monitoring. There are 6 properties of security. Again, when you can say security is something you need to worry about. If your integrity is broken, if confidentiality is in question, authentication, let us take each of them quickly what they are about. What is confidentiality? The device may store and transfer sensitive informations, okay, and that should not be revealed by unauthorized entities. Okay. So, there are confidential things, but only authorized entities they can always share it. Integrity, this is an effective checking mechanism to detect any modification during communication over an insecure medium. So, integrity is, you send data or you upload something, then it should not be compromised. Authentication and authorization, they are 2 terms, they are not the same, there is a certain difference. Authorization is here, that is only people or entities, they are authorized to access, okay, they are authorized to access the IoT system. it could be an object, a physical sensor device, those things. But authentication is to identify of entities, okay, that the identity of entities should be perfectly established prior to performing any other process. What it means, if I want to communicate an object machine to machine communication, layer to layer communication, okay, when do those communication, the communication won't pass until the entity is authenticated. So, authorization is granting access rights, authentication is allowing to talk. Availability, your IoT system is of no use if it is down. So, when it is down by compromising its security, it is down by accessed by unauthorized people, okay, or it is compromised by giving false authentication. Okay. So, availability is essentially is a service which must always be present, so the IoT system is healthy and available. Then non-repudiation, that is a property, okay. It is meant to provide access logs. So, whosoever login record is maintained, so that if something goes wrong, we can say who logged in last, what did he or she do, what or the machine did. Okay. So, providing an open transparent approach to keep a record of movement, record of use in case of IoT objects or IoT architecture, IoT system. So, pretty much the last slide is put in a picture form here, graph form here or block form here, passive threads and active threads. Okay. Passive threads is a confidentiality, the definition you know now, which is it collects data, eavesdropping or tracking users. That is basically happening. In case of active threads, is integrity, authentication, authorization, availability, the rest of them, and the examples are given here actually. Okay. In case of authorization, there is malicious input or virus or spam, ransom, Trojan, all those things actually the culprits. Okay. And sometimes data tampering, but anyway the whole thing, the active threats are all this. Okay. And these are the scope, you already know those things. Okay. Our idea is to see how machine learning and deep learning get engaged to the entire IoT system. Okay. Next is IoT attack surfaces. Okay, let us start from here. Okay. IoT system has got this is the physical layer or also the perception layer with the sensors. Okay. So, the potential attack surface actually is a physical device. So, physical device surface is a potential attack, and the attack could be physical nature, people can steal it away, or node captured by somebody, okay, or by eavesdropping, going for user tracking. So, this is how the sensors are compromised. Then at network layer, we call network surface, potential attacks like network services. Okay. How? Jamming, okay, denial of services, man in the middle attack, wormhole, sinkhole, eavesdropping, router attacks, attacks on network port, internet attacks, hacking, all those things are there. Now, I hope you know what's going on behind that, right? Okay. Or I can just tell me a few things. What is jamming? Jamming is your wireless, right. So, typically there is radio there. Radio is transmitting signal. Sometimes the signal too much. so that people get distracted and people get engaged and better good doing. Okay. Similarly, denial of service similar things, but at a different level being done that keep you engaged so that other actual processes services cannot be entertained. Man in the middle, somebody just goes inside the communication, say pretend himself is a good guy and try to do the both eavesdropping and general services. And because network layer router also are subjected to be attacked, their ports, so all those things. And if it is internet, all the virus, intrusions, hacking, they are all part of the attacks. Then the potential attacks also on cloud services, cloud as servers, storage devices. So, it is easy to attack them, and privacy. Okay. Then application layer, okay, application surface, typically that area using malware, spyware, virus, and denial of service, eavesdropping, bluestarping and bluejacking. What is bluejacking? This must be new for many. Bluejacking and bluestarping is the Bluetooth. No Bluetooth. So Bluetooth attack, jamming. Bluetooth jamming is bluejacking. Okay, and this is hacking with Bluetooth. Then the new ones, new attacks could be, because our IoTs are interconnected and the interconnection place is the weakest area. So, hit it there. Okay. If you hit it there or get in there, then you can, since they are all connected, you can get entire system, and particularly these days there are a lot of communication happens called interdependent IoT environment. What is interdependent IoT environment? You love to use your phone to control IoT. Any inside the house you have got many IoT gadgets. Okay, even your temperature control, for example, you want to control this is your air conditioning. There must be a smart plug to which that is connected. So you control the plug, that is taken care of. Okay, so and that plug you control from your phone. Then interdependent, which means your air condition operation management depends on your smart plug. Smart plug is connected here. So, you can always go to the environment, this environment, you can change things here, change things there. So, air conditions are affected. Then you have social IoT environment, all those Alexa, Facebook. Okay, there are a lot of things now, there are a lot of new things actually now. So, you can always go there and consider that as a great surface to attack and explore that environment and succeed. So, these are all huge IoT attack surfaces. Now, I think I told already these things. Yeah. So, okay. Yeah, I think I just talk about it. Yeah. There are 4 threat models, means security techniques for IoT. What are they? Who are they? Authentication that helps IoT devices to distinguish. This is echo. Is it echo? Okay. Is better? Yeah, it was too close to the, okay, now it is better. So, authentication helps IoT devices to distinguish the source node and the address identity based attacks. So, typically is pretend something and goes after it. So, it is stealing identity. Access control prevents unauthorized use
I mean, you don't expect somebody just strange to your area, strange to your domain, or user, not valid user of the IoT system can be accessing whole thing. Okay? So access control typically prevents any unauthorized user to stay away from the IoT resources. And secure uploading, and this is very important, particularly when you have got edge nodes and cloud. So you have got sensors at bottom, you have a maybe fog computing or otherwise edge nodes. Then from edge node you go to your cloud. Now we conveniently offload the computation. Okay? We conveniently take data from one level to other level depending on the need and when it is overcrowded. Okay? So, but when that happens, it is possible that the data could be compromised. So, you do not want a compromise of data during uploading. So, you need secure uploading. Okay. So, many techniques can be used to secure uploading. Okay. And malware detection. Malware is another new kind of, not new, they have been there forever, and every day thousands of new malware is coming because they are simple programs, short code with a malicious intention. Okay? So, a system has to be without malware, so we have to detect malware in IoT devices, okay, so that malware cannot steal the personal information or identity and exploit it to compromise the entire IoT system. And malware sometimes also deplete power by using the false identity and making it work. Okay. Like that you have got viruses and worms and trojans, what not. The 6 attacks on IoT devices: denial of service, jamming. Jamming is essentially radio transmission is a must. So the attackers send fake signal to interrupt ongoing radio transmission, and that way they can deplete the bandwidth, energy, and CPU power also being unnecessary wastage. Okay. Spoofing. So in spoofing is actually impersonates, means same thing, false identity, pretend to be a good, healthy node, good node with good intention, access the neighboring nodes in IoT system, okay, and particularly they try to mess up with the MAC layer by getting wrong addresses, and they try to make the communication system kind of havocked. Okay. Then fourth one is man in middle attacks. Okay. Be inside the in between the communication and use the jamming and spoofing. Again, software attacks similar to your malware stuff, privacy leakage. When do some kind of uploading, usually we use, because we have many elements, many entities on the way, we try to use a caching technique. The caching technique is, instead of the data being sent all the way to cloud, you keep it in between so that next time edge needs those things, you can get it quickly. Okay, the good intention, but those nodes, they are not very secure in between. Then the caching owner may be curious, they can try to see the data and get the privacy information leaked. It happens all the time. Okay. Suppose I came here, okay, they asked me to give my tax ID, give my passport details, so there are also my personal sensitive things, I leave it. Okay. Now, we do not know, maybe after several years, it may be hand of somebody tried to misuse it, they can do that. Okay? So, those kind of things are always there, and there is nothing much could be done at this point, except you have to keep everything. When they store all data, if they secure, they can encrypt it and keep it, is better. But who does that? Now, what you see here, different attacks we just talked about, putting here, then the techniques that will be helpful are also listed. Okay? For example, we need a strong authentication for avoid spoofing. Then this column tells that real techniques, machine learning techniques, sometimes it could be deep learning techniques, different algorithms, okay, that you have come across, SVM, KNN, all that nice algorithms being used, and how they are being used has been given the reference. Suppose you are doing research in certain area, 2-3 areas of these things, then you can go and read these 3 papers. Okay? So, this is one of the answers that, okay, if I have this problem, which machine learning technique I will be using to take care of that? It is one of the direct answer for that purpose of the lecture. Then, in addition to this, it also tells the consequence, the result, the performance is good or average, is bad, whatever the answer they got from these things are listed here. Now, let us take an example of how this machine learning based authentication in IoT system work. At least one example we can see, and that way you can find what is going on here. Okay? Now, this is IoT device. Okay? Now, this is another IoT device. Let us say this is a healthy device, and this is a device you are going to test. Is it compromised, something going wrong here? So, what is going on here? Okay? Now, they are supposed to be close to each other, first of all, in proximity. Okay? While they are in proximity, it make a request, an authentication request. In response to authentication request, it gives some standard answers, such as the frequency they are using, their identification, okay, and various signal features. It put together packets and give it to back. Now, because it is proximity, the same information also are available here, which is common. So, this is a common information. Whatever this device can sing is expected should be similar. But suppose there is something wrong here, then it gets information, data which are different. So, it brings it and kind of process it here using some machine learning techniques, and it can easily say, compare this with that and say, okay, something is wrong here. Okay, that result is given. Okay, hey, this device is in trouble, do something. Either you stay away from this thing or get yourself cut from this entire network. Yeah, that's what it's talking. Then machine learning based offloading, we said that, okay, you have many devices are here. Some devices are in the edge, some are in the cloud. So, you might be these devices are being using at the edge devices, then some going to cloud. Okay, and there are potentially jammers are there, the bad guy in the loop there, rogue edge, all possible things are there. Some smart attacker also attacking your certain devices, out of n devices, maybe few devices. Now, in this scenario, you always do offloading. Offloading means I need more computation, I go here, and then further more computation, I go there. So, when you provide some data, pass some data from here to here, do computational offloading, here to here offloading in this path. Depending on need of the more computation, you offload some other things. Then how do you know that during offloading things are not compromised? Okay. This is what happens actually. Every device, they have some basic status. Okay. There are two things you can get from the device side: environment state and data report. Environment state is saying, talking about what frequency they are using. Okay. What is the signal strength, just like the previous case. In addition to that, they also get some report. This report is about how they are doing last hour, last day, last month. So that data report, how safe they have been so long, is a kind of certificate that also get. So we call that performance evaluation, how it has been doing for a while. And environment state means the current status, various vitals of the device, communication, control, all those things. So we get observers, we observe that environment, and we also get this report, the quality report, basically the state, their certificate, how they have been doing over last days, weeks, months, depending on scenario. So that essentially called Q update after being processed to utility estimation. So what you get is kind of utility, they estimate it and bring Q function. And here you basically go for the state formulation, and these two are taken and analyzed here, and action is decided whether it is safe to upload or not to upload. So that means they create a policy that it is go for uploading or not go for uploading, and depending on that you upload or don't upload. This physical computation task will move or not move. So it measure look at the type of nodes, past behavior, this is current status, and combine that, build a policy and implement the policy to upload. Okay? Yeah, same thing talking about. Machine learning based malware detection. How machine learning is used to detect malware. Okay? Now, to start with, suppose there is malware, okay, it affects network traffic first. Okay? Get the vitals from network traffics. So IoT device always connected networks is get the traffic, particularly it goes and filter the TCP traffic. When it filters, it gets all those values, numbers, host post number, frame length, file type. So we call that as features. So network traffic is monitored, the device using network traffic monitoring it and filter TCP values, TCP traffic, and get those features out of the TCP traffic. Then once you get a feature, you apply the machine learning here. But before that, it does labeling. It does labeling, then apply machine learning. Not here actually, it started using it, but it will be applied here. So it gets the features, label the features, it stores the features in a database, then find and basically do a training. Okay, do a training and goes for actually clustering or classification. So the classification says something is if satisfactory answer is not there, satisfactory answer means when you go for this classification, you can find bad and good cases, compromised and uncompromised data from the clusters. So based on the label, it can say, okay, so many percentage. So if the percentage is minimal, then you can say it's good, but if it's kind of beyond threshold, you can say, hey, I saw the malware here. That's called malware detection. Okay? So the best way malware detection is to get the traffic features, label them, store them, and find a way, that's called training. Okay? Build the inference towards classification, classifier. So essentially, you have to classify and check good features and bad features. we know what is good features, but the feature you measure here, that will be divided into good and bad through the one of the classification technique. So if the wrong features are beyond certain threshold, then you detect that malware is an action. Okay. Then DL methods for IoT security. All that we discussed until that slide is machine learning, and when I skip something like this, means I have already discussed that while in the picture. Now, deep learning method for IoT security, just like machine learning, deep learning also being used. Okay. Now, they call deep linking is a protocol, okay, is used for security. So deep linking is a unified protocol. What it does, it permits IoT-based devices and their application to interact with one another in automatic fashion. Okay. Then the method also combines several processing levels. There are many layers that in your IoT. So it goes to even certain layers and learn the data representations at different levels, and compare with traditional machine learning methods. Then deep learning method have considerably enhanced state of the art. So this is a work done by a paper. What they did, they typically go to the environment. This protocol automatically try to communicate between device or layer to layer automatically, then get the data out from there, some features, you call features, representation, they get it from there, then compare that with the golden standard that has been done earlier. Okay. But your goal is to find deep learning method working or not. Okay. So instead of processing machine learning, you apply deep learning technique, that RNN, CNN, those things, and they found that the performance of this is better. There are some algorithms they are using supervised deep learning, that is RNN, CNN, unsupervised deep learning, then semi-supervised deep learning, or deep reinforcement learning. So if it's machine learning, it's just RL. If it's deep machine learning, that's called DRL. Now, CNN working principle for IoT security. So you have IoT system over here, then you go for feature extraction. There are so many layers you can add. More the layers, you can actually get more refined features over there. Then once you get the features, essentially, you can find potential outputs, and based on the output layer, you can say does attack, or is not enough, but I am finding some symptoms, then attack prediction, or there's no change, features are good, then normal. The only difference is you are using CNN there. So here actually this table, this table is 2 pages or so, then it says which method is using CNN, RNN, autoencoder, all those things. Then working principle is explained here, advantage sometimes is spelled here, then potential applications of IoT here. So this is another answer to our initial question, how machine learning and deep learning are used. And each of these you have to think is supported by the research papers. So if someone wants to do research in this area, they can read 1 or 2 papers very thoroughly, then go for their work. Both of them, 2 pages. Now, layer by layer, how IoT security layers based on machine learning, deep learning methods. Okay, so application of for machine learning, deep learning at various layers. How? Now, in perception layer, deep learning has been very promising, and they do authentication. So in other words, if you want to handle IoT security with deep learning technique in perception layer, then focus on authentication. Okay? Then if you are trying to find a scheme for to handle jamming, okay, use reinforcement learning. Okay. Then cognitive radios are very popular, okay, and they can typically learn and change based on the device dynamic environment. The main step towards accomplished cognitive operation is enabling CRS to sense and understand their working environment. Okay. Network layer, intrusion detection framework that is implemented in network level and constructed by machine learning algorithm to protect smart devices. Okay. So essentially saying that intrusion detection is potentially the weakness here and apply machine learning to detect that. Again, long short-term memory in analysis network traffic behavior to detect attacks and malicious behavior. Machine learning is used to detect anomalies. So ANN algorithm is being used. Further, for intrusion detection systems, you can apply unsupervised machine learning and you can find out that. So all this actually has been listed here because the survey paper has done something and there massive improvement in the performance. That's why they have kind of given a result form. AES, and there are also some of the reference given there. A generative model using AES is proposed to detect malware. So for malware, autoencoder is also used in network for network layer. Then this was new, just newly came, though its name was there for this network layer, this DBN, Deep Brief Network. Okay, this is automatic detection technique to malware, and it performs better than your traditional machine learning technique. In application layer, deep learning is used because in application layer your scope is large. Okay. It's also interesting to see because application layer is involved with social networking and all that. So I have not seen any paper on using LLM for that. So that's also possible new research avenues one can think about to applying that here. But all that is in kind of up to 2020 or so. So there, that time LLM was not there, or something, a small way, small form of that. Now, with the application of CNN in application layer, the feature related to malware detection is possible because many types of attacks happens in application layer because it exposed itself to the outside. Again, machine learning algorithm is also used to check whether the application layer is behaving normal or not, but in segment by segment. Training to adapt to attack, because attacks are keep coming, new malware is coming every day. So anything you do to find it to one kind of training today, it may not be sustainable for 1 month. So you have to keep training, dynamically changing, okay, so that the cyber attack will be limited. If you thought, okay, I learned these things, I'll be using it again and again, that's not the answer. Answer is it's a lifelong training to check new attacks that's coming here. Again, deep learning method models are more stable for cyber attack. That's they have found out. Earlier, everything was machine learning, now they are using deep learning. Okay? Because that provides higher accuracy and better scalability and less false alarm. Now, what are the workflow? Workflow is very simple. Machine learning or deep learning, you want to implement for security, protection, then you can see you can have a lot of data that to collect from the good sources and bad sources. Okay. Now, you collect large amount of data, then you pass it to this module where you can basically train it. TensorFlow is one of the example there. Okay. So, you can enable and get kernel or framework. Typically, the middle block is nothing but giving you the model, the rule that can be applied or deployed, okay, and check for any compromise, any security holes. So, what are the issues and challenges of future directions? First is availability of a security related data set. I can train my system to check something going wrong, it into a detection or anomalies, anything. I need data. Now, who gives me the data? Okay. Sometimes it's a real challenge to get good. Even now, people are always scratching their head where to get the quality data. Okay. So, how to extract or generate realistic and high quality data for training? That's a real challenge. Okay. Sometimes we think, okay, we can get some augmented data, maybe that looks similar. Okay, this will contain information similar to that. Then that don't work actually. It works in narrow way. Okay. So they should contain information that reflects nearly all the strategies in the real world attacks, and who give you that? Okay. Then the vital futuristic research direction is the crowdsourcing methods. Crowdsourcing methods, when you have situation like that, nobody is giving, so people volunteer themselves, okay, I pitch in something, you pitch in something, okay, then it's possible, but you know that when you give crowdsourcing, you may not be able to trust 100%. Then, although generating collaborative IoT data set, either this way or other ways, that is continuously need to be updated. Same reason, because attacks are newer attacks, so it has to be updated daily basis. What daily mean? Hourly basis, because tens of thousands of malwares get coming out every day. Okay. So these are serious challenges. Then, beside that, I always tell privacy issue is prevailing in most data set. So you can just get data with good faith, but you may be jump on a private data being collected here and there, and critical information could be also publicly compromised. Then, learning to secure IoT with a low quality data. Because when you try to train something or your model want to learn, if it learns from local data, there's no, you can get answer, but the quality will be similar. So you would like to have high quality data, or model has to show that even you get local data, it can still digest and come out with the golden answers. Okay. Most of the proposed deep learning representations are generally high quality data. However, IoT system comprise heterogeneous connected devices and large scale streaming, leading to possible high noise corrupted data to gather from such systems. That's basically making it low quality. Though your kernel is of good quality, but new data you generate is bad quality, and you always try to use some of the generated data to training, which means you are trying to corrupting your training pool. So learning to secure IoT data requires effective deep learning models that can handle even low quality data. It's very important, okay? Particularly when obtaining high quality training data is practically infeasible. Then the multimodal and effective deep learning models they should secure IoT system with a large scale streaming involving variety of devices in the presence of high noise. Okay. Then sometimes it is helpful if you can augment the data to improve training or learning performance. Okay. So that is, we need to find alternative means to obtain substantial amount of data on particular domain, and we call that data augmentation. Data augmentation is used to expand the limited data training data samples. In the augmentation of IoT security data, also the limited amount of existing IoT security samples can be utilized to generate new samples. It's chicken egg issue again. Then key challenge in data augmentation is producing new data samples that preserve the appropriate data distributions for each class. And normally, based on the domain knowledge, you can generate data that are close to the domain. Now, because of this scenario for augmentation, similar class, similar domain, okay. So because of this, we need suitable techniques that will be giving more authenticated augmentation and create data security data for training. Okay. Authentication cannot fully authentication, at least good quality data, I could say. And this needs actually a lot of new research. It's not been successful. We have been thinking in the last 3-4 years, if when you don't get data, get frustrated, why not to create some data? Because you are being system simulators experience, you love to create new data, but are they going to be any good? Who knows? Possibly not. Additional machine learning, deep learning challenges. So that is misuse of machine learning and deep learning algorithms by attacks, breaking cryptographic implementation, some reverse engineering techniques. Then privacy of machine learning and deep learning is always there. Privacy, just a blanket you can say, okay. There are always, privacy is an issue. The security of machine learning methods and insight into deep learning architecture. Quite often we use deep learning without knowing how many layers will be great, what is there, how the connectivity, how the weights are considered, those things. Then integrating deep learning, machine learning with other technologies for IoT security. Okay. Here you are addressing only deep learning, machine learning, but there are other techniques maybe combining those things to improve the overall secure scenarios. Okay. Then there is always a question, since the machine learning, deep learning, they are more compute intensive, how do you sustain them in the edge? And how do you kind of use offloading between edge and other nodes in the cloud? So we have to synergistically integrate machine learning, deep learning, and even new thing, blockchain for IoT security. A lot of work is going on last few years on blockchain area. Okay. Then the last one is actually the computational complexity. We know that the computation is a sensitive thing and offloading is a must to implement any machine learning, deep learning solutions, algorithms to be effective in certain bit layer or bit from the between two layers. So no matter what, the current solution of computation is using offloading and executing in the cloud. So that essentially is at the cost of more or less energy overhead. And the availability of application at top layer in this solution is also completely depending on the network condition from bottom to the up. So if your network connectivity is weak and you want to have offloading, then it is not going to help. You cannot even upload data from lower level to the higher level. So in other words, we need large amount of computation to be uploaded between low layer to all the way to cloud, and that uploading needs a healthy network connectivity. If network connectivity is weak, we cannot do that. That is a challenge. Another recent solution which may advance the implements of machine learning, deep learning in IoT security is developing edge computing. That is, you are asking, some of you are asking that. So GPU is used, so GPU, the thin client of GPU is possible. They call mobile GPU. One can use and try to solve that. So it's always trade-off you want to use. On the other hand, enhancing GPU-based solution and proposing efficient uploading strategy, suppose you are successful here, they're important in deploying your intelligent IoT security. On one hand, and machine learning, deep learning framework need efficient implementation to reduce compression on the other hand. So you have to essentially see how you can handle them. So in conclusion, the existing security trade-offs such as between availability and safety are another challenges. So what it means? It means if it is safe, system is available. If it's unsafe, unsecure, it's not available. Okay? So how much security will be providing to make system available? So that is kind of trade-off. Then in advancement of machine learning, deep learning, okay, many powerful analytical techniques are also there, and they should be considered to enhance IoT security. Everything is not done already. This is an opening, okay, and it's always a hot area, whatever you call it. So this survey paper that is in the first slide, actually, it has given various security threats, IoT attacks, and have discussed attack surfaces and talk about machine learning, deep learning, and uploading. So most of the painful issues and are addressed. At the same time, the three tables at least we saw that where machine learning, deep learning, they have been used, which author has did experiment and show the performance quality, which machine learning, deep learning algorithms are being used. So overall, this is a good survey paper that one can start who want to do research in this area. Okay, I think that's possibly the last slide. Questions, please.
Sir, what is the role of key management here?
Okay, yeah. So the key management is okay. We have this network, what we call wireless sensor network. The wireless sensor network is always having challenge for anonymous solutions. In other words, if I want to communicate from for authentication or then I have to. It's not about only encryption. Encryption comes as a second layer on that. Suppose I want to talk to you, but how do you want to trust me? So all the key management is basically to help to build a trust between the entities. Okay, they call it secure key management. Secure key management is about with multiple entities, multiple nodes want to talk to each other in order to make the reliability discussion. Then we all decide an algorithm. There are many algorithms there that we say, I give you this key, he gives that key. You don't know my key, he don't know his key. But when you get it, use a complete formula that has been a firmware there. We calculate the number, then it's acceptable, then we do that. Okay. That's basically the key management. A part of things basically, you must have seen the movies, right? You just tear this note, current note, and take it and match it. It's something like that. Okay. A malware question? Yeah. When you get a malware, we can always find a feature. Okay, describe the malware characteristic. So that new malware comes that way, you can catch. But unfortunately, we do that, but there's nothing else you can do. That's why we're doing it. Now, every day some new malware is coming. You try to match it. Not likely to match. Then you have to reduce your threshold. Okay, it is 50% matching. I should call it malware, or 30% matching, call it malware. So it's a kind of hit and trial kind of things. Then in this process, you find suppose the malware, then you build your new signature. This is how, this is my new malware. But it's always going on, tug of war. It's just like, the police and the thief. It's always going on. And it's always happening, one thing we don't know. Okay?
Once we develop sending and receiving and both are satisfied.
Right.
Any update occurs, any side, this key has to be changed.
Okay, the papers that we have done in this key sharing and key management, we found the robustic things, okay, very robust. And because it's nobody's changing that, okay. But what if somebody changed that, compromise, they found out that equation? So that's chances are there. And more recent work in using blockchain actually is more robust. So I have seen most of the newer people are doing using blockchain approach and addressing security. But overall, the key management used to be pretty strong until it is compromised certain way that it can manipulate that. And there are also new ways you can keep that hidden. Another an intrusion detection, intrusion cannot find that also. So it's a mixed thing. I will answer that way. It's a mixed thing depending on how robust is your key making technology or algorithm has been implemented there. And as another thing also, for authentication, suppose I want to access a device, a server maybe, for example. A server has to authenticate me. Now they are called biometrics authentication. Biometrics authentication, my ECG, the 2-3 features, my fingerprints, at least 2-3 features, they can be combined and created in an encrypted way. So nobody can check that until somebody impersonate me. Okay, then typically what we did actually, that one paper we did long time back, suppose I have got 11 biometrics things. I will not be using all 11 together. I may use 3 at a time, and I change those 3 every 2 months randomly. Then who can do that? So that's the safest technique. I combine 3 out of 11, and like that I do many permutations every 2 weeks, sometimes every week, and I know that when I'm changing. So somebody come impersonate, they cannot catch me. So that's the safest one at this point of time. Yeah, please.
So the signature we do is in the McAfee and the other, they have already the signatures of all the viruses. Can you use that as a data set?
Yeah, you can use, but as you just spoken, that they have data, this signature, you call it, signature for last 1 year, 6 months, but every day, they are not, these things are coming, new virus coming. So they have to change it. They are also changing it. So you can use data set, but if you are lucky that if you don't come across unknown guys, you are lucky. Okay.
Will there be any correlation between those signatures or no? They are independent.
They are very difficult to establish any correlation. That's why they're successful. They can malware every day. And there are people that are sitting there, the job is to, they're paid to write bad codes to alarm, unfortunately.
Yeah, I think they are attacking at the key generation, not at the...
They are not everywhere. Everywhere they can do it. Bad guy is bad guy. They can do anywhere.
Another important thing. They still use the equivalent for key exchange and all that.
Which one? New texts are coming up. Yeah, which one have you told?
UP help.
Okay. Yeah, they're still using. And also you have to consider that do you want to keep everything to high secure or low security? So security also are different levels. So you need to find out what you need.
Now if you try to see the electrical curves and all,
Yeah,
people are trying to use, that also they are increasing the bit size.
yeah.
That way it becomes a normal thing, it's no more for IoT.
It's almost like that, okay? So you use 8 bits, 16 bit, 30 bit, 128 bit encryption, all those are being doing there.
If it goes so much, then we cannot use it for IoT applications.
Okay. Now, sometimes we get so lazy, we write the password, okay, your name 123, right? So if you are living in that level, why you talk anything else, okay? And now I think they are now enforcing that, what they call that, I was having tough time.
Multifacial,
No, when a device is sold, they provide actually a particular code actually. You have to, based on that, you will be building that. Okay.
multi-language and all that started now in banks and all.
Yeah, but those, see, all that we're talking about authentication only. But authentication is a piece of iceberg only. Okay? Authentication, authorization is only one aspect. You saw so many varieties, okay? And many, at least authentication, quite often you get involved, but many authentication, authorization is machine to machine. It will be easily compromised. How can you handle that? But there's a way to do that. You can know measurement also. A lot of things have happened last 10 years in this security. But for IoT security, we have addressed actually many issues here. Okay, they are different. I told in one of the slides in the beginning that anything used for general one, not necessarily going to be used here. We need new things over there because every layer you have to make it secure, and some layers have a different challenges. We discussed those things also. This is a good paper. Please.
You suggest to concentrate more on device securities or network security?
All. I explain, okay, in security, it is like, you are carrying a pot with a lot of holes there. Water is, we pull the water, you are walking, and water is coming out. It will dry. So you have to close, not one hole or two holes, all the holes. So it's just scenarios like that. It is insecure all around. We keep making security more and more, something else is getting loose. And that's an ongoing process. We have to keep it secure.
But the devices what we buy, the bulb by the camera and all,
Yeah.
we are unable to put so many bits as a security and all.
Yeah, they have also ways, say, sometimes, even if they say recommend strongly, do this thing, there's a way also you can bypass that, don't have to do that. Okay. But that is not something we are discussing here. We are discussing about, in case of IoT, which one is more important, more to focus on that. Now, human effort has certain limitation. That's why the machine learning, deep learning are going to help you there. Blockchain going to help you there. And that's why you can apply those approaches in as much layer as possible, device level, network level, all the way to application level. Okay, and same time also, you see it's just like, when you upload things can go wrong. So this is a beautiful paper. I like this paper because it addresses a lot of things, and something not addressed after reading this paper, you have enough knowledge to even tackle that. At least think about that. Okay, there's no perfect answer for anything, so you have to essentially come up with it. As time changes, things changes. Okay.
I have read one paper, they have used the power attack and they break open the house and rent it.
Oh yeah.
Because on the camera it is blocked, everything is
Oh yeah, that
and they broke open the house.
that happens all the time. Yeah, even it happened when last week also, where also I saw some news. And the more thing is that they have now new mask. They put a new mask now, and the mask looks like if I am going, I will look like you. So you'll be in trouble, but they're not proven not there. Okay, so the mask is given as if it's
Here they have used bot, UOT bot attack,
yeah.
and it has blocked the network.
Right.
They have safely went in and
That's
keyboard,
possible.
that's
Yes.
the realization.
Yeah. All kind of that is at least a low tech. Okay. Now we are talking about That's one spot case, but we are talking about tens of thousands IoT elements are deployed globally, and something happens, it can create big problem. Okay. Thank you very much. It was nice to have you. Yeah. Or if you have other colleagues doing research same area, so please we will definitely meet and discuss some papers. That is a must. It's just like now doing exercise yourself for your body and mind. For mind, it's necessary. Okay. Then when you read a paper, don't read the abstraction, stop it. Read the introduction part, and that will tell you whether you should invest your time to entire paper or not. If you read one or two papers very thoroughly, good paper, not any random paper, thoroughly, then you will be able to progress new research in that area. Okay. And if you have got a student who is working, ask him to read paper and present it. At the same time, you also get involved in that. Sometimes we learn many things, we learn from students. Okay. New techniques, but they talk somewhere, then they talk, they ask you question, then you get triggered. Okay, that's the fact. And anytime you can definitely, there are many instances you'll find you are stuck. You don't know how to go, where to go. Okay, and you may not have a direct solution, but there are few things. Number one is you might find Google the best friend. Okay, and this other thing is do not read those papers. There are many papers I have seen these days, the name of IEEE coming here, coming there, but they are not worth reading also. So you have to be very careful, because your time is precious to you. Okay. That's actually the biggest challenge is many faculty, young faculty, they are starting research, sometimes they don't understand the entire paper. So they want to read a paper easy, so that they can understand that. And when they read that paper is nothing. So you are basically in a nothing zone. Okay. So, and if you don't understand paper, that's okay. First time not, second time, and when you read a paper, don't read blindly. When you read a paper, as if you are getting a story, think about it. You must have read some fiction stories. When you read a fiction story, what to do? You are reading something, then you start imagining, oh, this next step, this will be done, next step, that will be done. Okay. So like that, when you read a paper, you think the author must be doing that, must be doing this. Same concept, but then there are two possibilities. Maybe author has done that or not done that. If not done that, then you are winner. Okay. If the author done that, you feel happy that he has done it. Then what he has not done, let's explore that. So almost intuitive things, but throughout all this exercise, you will find some resistance. Don't stop there. You continue moving on that. And some idea is bothering you, let it bother you. Don't desert it. Eating, sleeping, driving, thinking about it. After 1 week, 2 weeks, 1 month, it will surface, answer will be given to you. Okay. What else you want to know?
So I also told them that in case if they want some interaction with NIT or yours,
Yeah.
yeah,
You can. This is this. Yeah, your Google Meet, Zoom is so easy. So even it's possible that some faculty, some here in 2-3 places, they have common interest. They can always get out of Google and meet weekend, weekdays, some time. Do that.
And good option is pick up a paper which has lot of citations. More than it has been referred. Recent papers will not have that.
Survey, yes. So survey papers are best to start to know the area, just like now. Look at this, how much information is given, just 1 or 2 papers. See, somebody in this paper, they know the physical state of art going on in this area over so many years, most recent one, for example. Okay, then that gives, okay, this has been done, this has not been done. And often you can borrow the ideas implemented in domain X and apply the domain Y. That is absolutely good reason to do that. So research could be very different types. Some research could be just from nowhere you get something. That's very difficult research. Okay. Sometimes some research is similar in one area, but that idea not used in another area, but is applicable. That also you can do it. So slowly you grow. Once you do that, then you are mature. Then you can attempt higher skills. Okay. If you want to stay in the same level all the time, then growth will be less. So you will be challenging yourself. Actually, there is no other thing. Okay, research is like that. So that's why everyone don't do research because of that. Okay, but that's fine. Okay, it's not that everyone do research. But since you are here, I'm assuming that you guys are seriously considering the research. Okay, with your students. So a few things that we discussed. Follow that. Keep regularity. Read paper. Okay, discuss it, and continuously look at the areas of your interest. Don't jump all over forest. Look at the particular area and find out that there are conferences in that area always going on. Every year, there's a series of conferences going on. So focus on 3, 4, 5, depending on the area for interest. Then see a new paper is coming or not. Keep track of that. Okay. Because if you want to do a paper, then you have to be, otherwise no, some idea sometimes is similar, they do it, you are not aware of. That happens a lot, but now with all that, I believe you can access to all the IEEE mega journals now without difficulties. But many years back,
National Library.
right, and when you are doing PhD here, it is not possible. You have to go to library. Now you don't have to go to library at all. Okay. Some initiative to be taken from now to be taken by you to pursue your own research, but all standard things are here. Okay.
Can we take some questions from?
Yeah, of course.
You can just ask whatever you want.
Yeah.
It comes to which are hardware or software. Some questions if you want you can ask. It is nothing that
Some idea which stuck in simulations. So whatever the theoretical we have done, you can come into the intuition what you do. When you want to prove it that one here, simulations. So what is the best way to go for it?
Okay, you mean you have some idea,
Yes.
okay, and that idea you have to validate, because most people that come here, I consider them as the system research of systems, which means you will be coming up with some ideas to, we call it a problem statement, you can, or you can just call, okay, this is what I read this paper, and I saw that the authors have done this work, but they have not done this part, and that could be low hanging. I can always do that, pursue that, and get my research. Okay, so when you say they have not done something, you can do, that should be significant. Okay, then you have to validate that. How do you validate? Either hardware, software, or combination of that. You call that simulation or emulation, whatever, right? And you need actually two things. You need a platform or environment or framework, whatever you need. Okay. Then after that, you need also the benchmarks. Now, to do that's actually vital. In sense, if the authors have used some benchmark, you can even ask them sometime. And many times people put their code also on the GitHub. So keep visiting that also. Okay. Then you start implementing that, use the same benchmark. That way, whatever result you get, you can compare with them. If you are using your research in the machine learning things, so you have to use a large amount of data. There are standard benchmarks available. You can get it. Okay, and your question was what to do with simulation or how to go from just simulation to hardware? Hardware, okay. Now FPGA is one of the ideal path, but are not, unless it's a small project, if a small project you can buy FPGA and do it, it's very time consuming. But none of the projects in this machine learning area are small. So I started talking to some professor here who is doing that, okay. So it's very, very frustrating. You buy hardware, you together, making it to work is not business. And fortunately, Amazon and other platforms offering huge GPU or FPGAs, offer to you. So you can always do that. That is your instrument on the cloud. Similar results, the things you cannot do because you have to do in scale, because you write a paper, give it, immediately they reject it, saying, okay, we expect you should have a bigger scaling factor, not only taking data up to 1,000 or 2,000, should take about million data. Okay. So those things you can only do in the cloud. And dealing with the cloud, first time is challenge. Once you learn it, you love it, and it will be easier for you to manipulate. First time is resistance, you don't have to learn how can I connect there. Then how can I get a result. But you need to know that if you turn to measurement, that's a very tricky thing, because in measurement, kind of like timing measurement in particular I am talking about. In timing measurement, if you are using cloud, you cannot rely on that, because you do not know where the timing is stock actually. Before you say compute, but then actual computation, it's not little bit time. It may go somewhere because there are many people are using it, time shared, batch mode. So you have to be very careful. If you write a paper and say, okay, this took so much of time, that is difficult. So you have to find a way. You have to know that when it actually work started there, record time there. Okay, in the code actually keep time tags. Then when it answer come time tags. So there are ways you can source and find it those things. So hardware is the cloud, not. So I don't encourage people to spend money on GPU. Is okay, small. You need GPU. Some of the small medium class applications is good, but very large benchmarks, you cannot handle that.